So good afternoon. This afternoon we're going to work with graphing linear inequalities. It's not equalities, but inequalities. Now remember our inequality symbols, we have the less than or equal to symbol, the greater than or equal to symbol, this is our less than symbol, and this is our greater than symbol. So what we're going to have then is this linear inequality. So we have like y is greater than or equal to 3/5 times x plus 2. Now we recognize that this takes on the concept of a linear equation. The only difference is we're not going to use an equal sign, we're going to use an inequality symbol. Our strategy we're going to use with these inequalities is we're going to identify the slope and the y-intercept. Looks like I need to spell that a little bit better. Y-intercept. See if I can clarify it a little bit better there. Y-intercept. So we want to identify the slope and y-intercept. We want to graph the line. When we graph the line, though, it's either going to be a dotted line or it's going to be a solid line, depending on our inequality symbol. Now, to pick up on is, if it's less than or equal to, we're going to be using a solid line. If it's greater than or equal to, we're going to use a solid line. If it's a less than symbol, we're going to use a dotted line. If it's greater than symbol, we're going to use a dotted line. So once we graph the line, we're going to test a point that's not on the line. In other words, we're going to pick a value for x and y that's not on the line. We're going to test that point to see if it makes the statement true or false. If the statement is true, we're going to shade the side that that point exists on. If that is false, then we're going to shade the other side of the line where it would end up being true. So what we want to do is find out what the solutions are to this inequality. But to find those solutions, what we actually end up doing is graphing the solution. So, as our strategy said, we want to identify the slope and the y-intercept. And remember, we have y equals mx plus b. If an equation has that y isolated, then that coefficient of the x is described as our slope, and that constant, that b, is considered our y-intercept. So we pick up on that m is equal to 3/5. That's our coefficient in front of x. And our y-intercept is equal to a 2. So using this information, we're going to graph our line. Now remember, we have to use our y-intercept first because that's actually on the line. So 0, 2 would be on the line. And our slope is this 3/5. So we have to go from this point. We have to rise up 3 and run 5. So from here, 1, 2, 3, we run over 5, we would have a point about here. So that's not too bad. Make a little bigger dot. Now I really can't rise up 3 to run 5 again, but notice that if you make this a negative and a negative, I could run down and run over, so I can go down and left. That should also be on the line. So 1, 2, 3, and go over 5. That should make a point that's located about here. So, using our straight edge, we're going to line up these points. We also got to pay attention to our inequality symbol. Since this is a greater than or equal to symbol, the points on the line are going to be part of our solution. So, it's going to be considered a solid line. So I'm going to line up these points, and I'm going to draw a solid line through those points. Didn't really hit it very closely there, did I? So, make that a little bit bigger there. Make that a little bit bigger. So that's going to be our sketch there. Graph paper would come in a little bit more handy than just freehanding it. So I've got my line graphed. I've determined that it is a solid graph because of this inequality symbol. Greater than or equal to is going to be solid. I'm now going to use my third step is test a point not on line. So if I look at this graph, a good point to choose is 0, 0. Because I can usually evaluate 0, 0 pretty easily. So I'm going to choose a point that I find easiest. So I'm going to choose the point 0, 0. So I'm going to substitute the 0 in for x and the 0 in for y. So 0 goes in for y. I have 3/5 times 0, and I have 2. Notice that that's why I like to choose 0 for x, because this just zeroes out. So what you have is then 0 is greater than or equal to, and 0 plus 2 is 2. So if you look at that inequality, is 0 greater than or equal to a 2? I would say that's a false statement. 0 is less than. So what this is telling me then is, I don't shade this side because it was false. What this is telling me is to shade the other side. So I'm not going to really shade. I'm just going to kind of make some marks like this. These marks indicate that any ordered pair in this region, if you will, above the line, should satisfy this inequality. So there are a lot of ordered pairs out there that we have that are solutions to this inequality. And what we are doing is letting our graph describe that solution. So that's kind of our goal here. Okay? So we'll stop there, and we'll try to do one more lesson with you.